Okay, so welcome. So basically today discuss about that crop yield prediction. Okay, help of machine learning, how we can easily predict the crop. Okay, or predict the productivity. Okay, so today session discuss about that how we can easily predict the crop. Okay, so I'll try to explain all of things from beginner to advanced level, and I hope we can easily get the idea how we can easily use the machine learning, and then how we can easily predict the productivity, okay, as well as how we can easily make the productivity map. Okay, so I will try to show you that all of those step by step, then you can get the idea. Let me share my screen. Can you see my screen? Okay, so let's really start. So first of all, you can simply open your terminal. This terminal we need to active our environment. So I already created the environment. So previous class I discussed about that how we can easily create the environment. So now I want to active this environment. So I simply write here conda activate and put my environment name. Okay. So my environment name is that Geo AI. So this is my environment name. I simply active. So you can see it will be activate. So it shows the Geo AI in here. And further we simply open our Jupyter lab. So just I simply write here the Jupyter lab. Okay. Just write it and then open. So now it will be open our Jupyter lab. So where we write our code. Okay, you can see it will be open. So you can see it open this type of folder. So basically it's the default folder. So this is the default folder. If you want, you can also open. So I already discussed about that. So now I want to work with this folder, and I just work with Python 3, this notebook I try to create. And further I want to predict the crop yield prediction. So for that I need some data. Basically I need the boundary data, boundary of my field, as well as I also need the data for some ground truth data. Okay, suppose soil moisture data, or also wind speed data, suppose, as well as also yield data. Okay, so basically this type of data we are just use in our machine learning, and further we simply predict the productivity. Okay, so let me open my data. So it is just stored in my download folder. So in my download folder, if you check, this is the folder prof yield. So here I find out this type of CSV file. So basically this type of CSV file, it stored the data. Okay, so it stored the moisture data for my field, mainly latitude longitude. Okay, for this type of field, or also speed data, or wind speed, or also weight data, or also yield data. Okay, so this type of data I need to work in my model, in my machine learning model, and further I just simply predict the productivity. Okay, so for that, first of all, we need to open the Python 3. Just I simply open. So just I simply open in this, and I put the, you can also click on here and put the rename. Suppose I put the rename as, I put the name, suppose crop productivity. Okay, you can put any name. So this is my Python. I just simply create this notebook. So now I simply write my code. So first of all, we need to import some important packages. I need to import. Suppose first package I simply import one package. It's called that import GeoPandas. Okay, this is my package, and I rename it as a GPD. Okay, I put this type of name GPD. I also import another package which is called the NumPy. Okay, NumPy as NP. I also import another package matplotlib dot py pyplot as plt. Okay, Then I simply import pandas as PD. I also imported the seaborn. Okay, just import seaborn. This is another Python package, seaborn as SNS. Okay, you can put any name. So I simply imported this type of package and run, just run. So now I can see it loaded. And this type of package I already imported. Okay, I already imported, but it show the one problem, matplotlib. So matplotlib.pyplot, no module it shows. So let me check the spelling. Okay, now let's run the code. So now it's what, there is no problem. So matplotlib.pyplot splt, so it's imported. So now this type of CSV file I need to import in my code editor. Okay, so for that we simply take the variable, suppose path1, and I want to read. So you can see basically that the total 1 2 3 4 5 or 6 CSV file is including the different types of information. I think another file it is stored in here. Let me show you that another CSV file. So this one field CSV. So just I simply click on here. You can see, just copy the path, and I just simply write the code. I simply store it. Okay, first of all, I simply store it, this type of data. So this is the for the path one. I simply store it the one CSV file. Take the another variable, suppose path two. I simply store it the another file, which is stored in this folder. Prof yield. So just I open this folder. Suppose this one, just I simply copy the path and then paste here. Okay, then another, suppose path 3, just I open this, just copy the path of this file, just copy and then paste here. Then path 4, simply copy this path, and paste here. Then path 5, store it this another CSV, copy path and paste here. So we simply input all of data. Okay, path 6, just copy this path and paste here. So now run the code. Okay, so there is no problem. So now this type of file I want to read. Okay, so basically when you read the CSV file, we need to use a Python library. It's called the pandas. Okay, we need to pandas library. I put the pandas library as a PD. So just take a variable. Suppose I put the variable name df1, and I simply put here, call the PD dot read CSV. Okay, and then just call the path1. I simply copy and paste it. So now this same line we simply run. Suppose 2, then 3, then 4, then 5, then 6. I simply change the name. Suppose it's a path df2 and it will be part 2. So I simply store it. Then it's 3, then 4, then 5, and finally it's 6. I will change the variable name. Suppose df3, then 4, 5, and finally 6. So I simply read, but we face a problem. This problem, it show the result. Okay, PD read CSV, it show the problem keywords refine the default rate. Okay, so this is the no such file directory from this folder. It show this type of problem. Okay, let me just a minute. Let me open the terminal again. Suppose I put the panda activate GeoAI and I open the Jupyter tab. Okay, so now it's open the Jupyter lab. So it's don't get the path. Okay. So I create this in here, this file. I imported all of library again. Pandas as PD. Import GeoPandas as GPT. Import matplotlib.py plot as PLT. Then import numpy as NP. Then import Seaborn as SNS. So I import it. So now I simply create a path 1 and suppose I just call one CSV. So this CSV I simply copy the path and paste here and run it. So I put the df1 and I want to read it. So call the PD and put the read CSV function to put the path. Oh, what is the problem? It show the problem no such file or directory. It cannot access the file.
Why?
Okay, I think some problem for the kernel or this folder. We face some problem. Okay, let me reopen this terminal. Suppose I active the panda, activate GeoAI. I put the suppose CD or change directory. I simply go to the download folder. Downloads. In the download folders, I simply open the Jupyter notebook. Suppose Jupyter lab. So now it directly open the download folder where we find out the directory. Okay, download folder. So now we can easily access the download folder. So this is the download folder, all of those are in here. So I want to create my folder, Python notebook folder. I simply open in here. Okay. And now let me try, suppose import pandas as pd, take the new cell, suppose path1, and copy the path. So I copy the data. So this file, simply copy and paste here. Okay, and then I want to read it. So df1, call the pd dot read csv. Okay, and then put here path1. Yes, so now it's worked. Yeah. So that's why we find out the result. So now the same process you just apply and also import it.
Sir,
Yeah, please.
what was the problem?
This problem is that we just use the same directory. Suppose you can check this file. Basically, this is my data. This data, suppose this first data, it is stored in my download folder. Okay, in my downloads folder. As well as you can see,
Yes.
this type of file, suppose this is another file, but this file in my download folder, and then when I open the download folder, then I also get this type of folder and also get this type of data. Okay, so now let me show you that it will be work or not. Suppose just I simply call the path q and call this, just simply copy the path and paste here. Okay, so now you can see what happened. So this folder, this is the folder. This folder is stored in my download folder. Okay, this folder is stored in my download folder, and this notebook is also stored in my download folder. This notebook also stored in my download folder. So now I hope it will work. So just run the code again, and I take the another, suppose df2, and call the pd dot read csv. So now put the path q and run it. So it works. There is no problem, you can see. So this is the problem, is that first time we create the another folder, suppose all of data in my download folder, but I just create the notebook in the another folder, not download folder. So in this case, I just simply create this file in my download folder. Okay, so that's why all of data from the download folder I can easily access. So this download folder is the mother directory. It's a mother directory. Okay, this download folder is the mother directory, and in this directory I can create my file, create my Python notebook. Okay, just I rename it. Suppose I put the rename is prop productivity mapping. So I put this type of name. So now you can see I have a mother directory. This is my download, and this download I simply create my Python notebook, and now all of file I can easily use. Now in my mother directory I can easily use in my Python code editor. I can easily use all of file. Okay, because my first file is the download folder. So further I simply create this file in the download folder. So now in the download folder, all of file I can easily access in my code editor. Suppose I want to access another file, this one. Suppose I create the another, suppose path 3, then suppose path 4, path 5, and path 6. So I simply put the equal sign and simply just copy the path. Just I copy the path and paste here. So this is the field 3. Paste here. This is the field 4. copy the path. This file name is that 9. Okay, this put here and put the file name, it's a 11. So now run the code, there is no problem. So now I create the, just simply read all of file one by one. So df3, then 4, 5 and 6. So I simply put the, it's a 1, 2, then 3, 4, 5, 6, and same as 1, 2, 3, 4, 5 and 6. So now run the code, there is no problem. Okay, so we simply use the CSV that contain all of sample point for my croplant with their different types of ground truth information. So I want to read one. Suppose I want to read the df1 data, and check the data. So you can find out this type of you can say the x and y. Okay, x and y value, basically latitude, longitude value, and also get the moisture value. It's a ground truth, then speed value, wind speed value, then width of the land, width, and also get the yield data. Okay, and yield per acre we also compute. So now this is my data. So all of the similar data, you can see that df2. So this is another field data. Okay, this is the df3. So this is another field data. Okay, different data. But I want to compute the productivity at the same time all of land. Suppose field 2, it's a one kind of land. Field 3, this is the another land. Field 4 is this is the another land. So I want to compute the productivity mapping using all of CSV file at the same time, and then try to show you that how we can easily work. So now this x and y, you can see we find out the x and y. Okay, this x and y coordinate we need to convert into GeoDataFrame. Okay, so we need to convert the x and y into GeoDataFrame. GeoDataFrame, basically when you convert, then we can easily plot this type of latitude, longitude in our map. We can easily plot this type of latitude, longitude. So for that we simply use the GeoDataFrame. Okay, from the GeoPandas we simply call the GeoDataFrame. So for that, just take a variable, suppose gdf1, and I call the GeoPandas library, GPD. So I already defined the GeoPandas. Oh, need to define the GeoPandas also. So import GeoPandas as GPD. I put the name GPD. So just simply I just use the GPD. So from the GPD, I just simply call a function. This function called the GeoDataFrame. So put here the geo, then data and frame. Okay, just this function GeoDataFrame. So I want to create the GeoDataFrame for df1 for this data df1. Basically this x and y, it convert the GeoDataFrame. So just I define. Okay, define, and we need to define the geometry. Okay, we need to define the geometry. So for that, another argument is the geometry. Put here the geometry equal, so we call the GeoPandas library GPD, GeoPandas library, and use the function points from x, y. So it's one kind of function. So when you work with the latitude, longitude or x and y value, so need to put the function points from x and y. So now these points, it's come from df1, first df1, basically this data df1. From the df1, if you can see the df1, if you just we find out the x and y. So df1 x and y. So I simply define df1 and apply the dot x column. Okay, x comma, again call the df, it's a hyphen also. Okay, so this is the hyphen, and also put the df1 dot y. So I define my point, or also x latitude, longitude, I simply define. Okay, As well as if you want, you can also define the reference system. It's called the CRS, coordinate reference system. So we just use at the EPHG value. So for this study area, EPHG value is that 32618. So this is the constant value for the, so you can easily find out for any study area. Simply search what is the EPZ value. We can easily get it, this type of value. So now I simply copy the same line of code and I need to apply for all of others. So suppose GDF2, I put the DF2 data and also put the DF2 from the X and DF2 from the Y. Okay, same. So then put the another, just paste here, and I put the GF3 and put the DF just 3. Just simply change the variable name 3. Okay, others keep the same. Then put the GDF4, change the variable, then call the dataset DF4 and also change the DF1, basically it's a DF4 and also it's a 4. Others keep the same. Okay. And finally, simply put here, suppose for the 5, put the DF5 and finally last one, we convert the GeoDataFrame X and Y. I put the GDF6 so CRS, just I keep the same. So run the code. So now it's worked, there is no problem. So now take the new cell. So I have to add the plot and display this type of point. Suppose I just simply call this variable GDF1 and I have to display. So just use that the plot function. Plot. So now run the plot. We create this type of plot. Suppose I want to check the another, suppose 3. Separate this type of plot. So this type of training sample or training point or point, we find out this type of point. Suppose 6. So we find out this type of point. Okay. Suppose this is the 4. So it is easily display this type of points. Okay, which is indicating different types of information for our profile prediction. Okay, so we can easily get this type of point. So now we need to make the merge. Okay, we need to make the merge all of point together. Okay, so we need to merge all of point together. Suppose I need to merge GDF1, GDF2, GDF3, GDF4, GDF5, GDF6. So all of those I simply merge. So let's join the GeoDataFrame together. So for that, simply take the new cell. I take the new cell in here, take the new cell and simply join. Okay, so how I can join? We are just use the pandas function and join. So for that, take a variable, suppose GDF full. So I simply call the pandas PD. From the pandas, just call the concat function. It's mainly useful for joining all of those together. So I simply call the GDF1. Okay, then just make a list all of those. So put the square bracket and then put here the suppose GDF2, then GDF3, GDF4, GDF5, GDF6 and make the list. So now run the code. There is no problem. You can easily get this type of things. And if you just make the plot, suppose just call the GDF full Simply make the plot. So put here the PL plot and run the code. So now we can get, so this is the one field, this is another field, another field, another field, another field. So 1, 2, 3, 4, 5. So this type of field we can find out. Just simply combine 1, 2, 3, 4, 5, and 6. Okay. So after this, we simply use the help of, so in this case, suppose I want to work this type of data. Suppose I want to work with the moisture data, mainly moisture column. I need the, suppose, speed or speed data, will speed data. I also need, suppose, width data. Okay, width data, and also work with the yield data. Yield data, suppose per acre. Okay, so per acre. So I need this type of column: moisture, speed, width, and this yield data I need. So I need work 1, 2, 3, and 4. Just 4 column I need to work. But if you check in our data set, it's have the X column, Y column, time stamp column. Okay. So now how I can remove this type of X column or Y column or time stamp column? I just simply remove, as well as also yield column. Okay, because I want to use the yield per acre. So this unit I want to use. So how I can remove this column, also time stamp column, X column, Y column, or with unnecessary column, how I can remove from my data set? So for that, for the removing this type of data, so just take a variable. Suppose I put the variable name is that, I put the same variable, suppose GDF full, and I call my data. So basically this is the GDF full. Just simply copy and apply a function. It's called the drop function. Drop. Mainly I simply use the drop function for drop out all of column, unnecessary column. Okay. So now I define the all of unnecessary columns. So just I use here the columns and make the list all of unnecessary column. Suppose I need to remove X, it's not need. I want to remove Y, it's not need. I want to remove the time stamp column and also remove the yield column. So I simply use this drop function and mention the column name. Which column I don't need. So I simply run it. So you can see now all of column will be removed. So I want to display what happened for this. So you can see now you find out the only for the specific column. Okay, moisture, speed, width, and yield we can easily identify. And now X, Y, time stamp, and yield. So this type of column is removed from my data set. So now I want to check from my data set some statistical value. Okay, suppose I want to identify the standard deviation value, minimum value, maximum value, then mean value, or 20%, 50%, 70%. So this type of data I want to identify from this data set. So just I simply copy that data set, and when you use the calculate the different types of statistical value, just apply a function. It's called the describe function. Okay, describe. So when I apply the describe function, it automatically, you can see, compute the mean of moisture value, mean of speed value, mean of yield value, mean of yield prediction value, standard deviation value of the soil moisture. So minimum 25% percentile, 50% percentile, maximum value we can easily identify. So 39, this is the maximum value of moisture, this is the maximum value of the speed, this is the maximum value of the weight, this is the maximum value of the yield. We can easily get this type of information when I apply the describe function. Okay, so simply split and also check the result.
Sir,
Yeah, please.
what are the unit of those data? Moisture, speed,
Okay, so this unit,
for example, speed
yeah,
is meter.
yeah. Suppose the speed is the meter per second.
Yes.
meter per second, width is the meter, soil moisture millimeter. So this type of, you can put any unit, you can compute this type of data. Okay, then just simply use the same process. Okay, but it just simply use suppose millimeter, then speed is that meter per second, width is the meter, and yield is the per acre. So now suppose I in my data set have some null value. Suppose I have some null value. So I want to remove all of null value. So how I can remove the null value? So for that, you can use the take a variable. Suppose I put the variable name is that GDF. Suppose full clean. So clean data. I simply remove all of null value. Suppose I have any column, there is no data. So I simply remove this data. So just I simply call this variable and call my data set. It is stored all of data, and I apply it and apply the function drop NA. Okay, and run. So now it easily remove all of those data and store it in this variable. So now all of null value will be removed and stored in here. So now there is no null value, we can easily find out. Okay, so in my data set, but sometimes suppose if you have any null value in your data set, so then you can simply remove using the drop nav function. So now for that, we try to check the correlation. Okay, we make the correlation matrix between the variable and our target productivity variable. Okay, so in this case, I want to identify our correlation matrix. Suppose in this case, our variable, in this case we are just using the moisture, it's one kind of variable, then speed, then width. Okay, so this, and also yield data. So this is my variable, this is the variable. Okay, prediction variable, or it also say the variables. Okay, and our target productivity, so our productivity I want to identify using the geometry. Okay, using the geometry I want to identify the productivity, or using the point I want to identify productivity, and this is my variable. All of those are the variable. So now I want to create the confusion matrix table. So from the confusion matrix table, we try to identify correlation. Okay, suppose which one is the more correlation. Okay, so which one is the less correlation, you can easily get this type of idea from here. For making the correlation, first of all, we simply drop out the geometry. Okay, because geometry is not neat when I make the correlation. So I need only for this type of variable. So for that, just take a variable. Suppose I put the variable name is suppose df full, and then I want to identify. Okay, we also need to upload the another package. It's called the matplotlib, because I want to make the confusion matrix or correlation matrix using the matplotlib and make the chart. Okay, of the correlation matrix chart. Okay, so import matplot library pyplot as plt, and also import seaborn as SNS. So now we simply drop out the geometry column. So I simply call this GDF full clean and apply the graph and mention the columns equal, just put the column name is geometry. Okay, so now this geometry is removed from this data set. If you check the data set, suppose df pull and just show, you can see there is no geometry column. So now we want to make the correlation between this type of variable. So how I can make the correlation? Use this type of variable. So for that, simply call the PLT. I want to make the figure. So I put the figure and apply the fixed size. I define suppose fixed size is 12, 13. I just define fixed size. After that, I want to add suppose heat map. I want to create the heat map using this type of variable or correlation. So for that, just put the SNS. Okay, this is the Seaborn library. This Seaborn library help you to create the heat map or correlation heat map. We can easily generate using this library. So just I call my data set. So this is my data set. This is my data set. So this data set I want to use, and I create the heat map. So put here the heat map and apply this data set, and I just apply the correlation function or core function. Okay, so now run the code. So it create this type of heat map but not showing the value. Okay, so moisture value, speed value, we don't find out the correlation value, this type of variable. Just create the heat map. So I want to add this type of value. So just I add the annotation. So put here the annote equal true. Put here the comma sign. So now you can see find out this type of correlation value for each variable. For the weight, you can see moisture, speed, weight, and yield. Then we find out the, you can see the yield, weight, speed, moisture. So it one kind of matrix. We find out the this type of matrix we can generate. Okay, and you can see this type. Also check the legend about that. So it's indicating about the high correlation, this type of color, and this type of color indicating about the low correlation value. We can also find out in here. As well as if you want, you can also define the minimum and maximum value. So I define suppose v min equal -1 and v max equal +1. Run the code. So now it also get this type of result. You can see we can easily identify. Okay. So this is the correlation matrix we generate for our variable. So now how I can apply the machine learning? In this case, how I can apply the machine learning? So in the machine learning, when you apply, so in this time we apply the linear regression method. Linear regression, and we create the variable x and y, divided data into training and testing, and applied the linear regression model. Okay, so these are main output. So we create the x and y. Okay, x and y data. Okay, so let's go try to create the x and y. So this data, we just simply spilled x and y. So data set is spilled into x and y for training and testing, and further applied the linear regression model. So this is our main goal. We are just create the spill the data x and y. And this is our full data. So this is your data set. So now I just take a variable x. Okay, so just I simply x equal. So I call this dataset. So from this dataset, I apply the drop function to remove the column. So I simply define the columns equal and put the column name. So I am to remove this column. And also take another value y.
Sir,
Yeah, please.
now we are going to use X. Which data is going to be X?
So we create the
X
two.
is the independent variable, is it?
Yes.
Now,
So,
which column is going to be independent variable?
so now we are just use only for this type of data. Okay, only for this type of, suppose width, speed, and moisture column. Okay, it is spread
Yes.
in the x because
Yes.
I remove the this one. Okay,
Yes.
and
Now 3 columns remain.
yes. So we are just without this column, we simply take others column. Okay, so this is our property, and y column.
Yes.
This variable is stored. Okay, suppose this y. So from the df, from this data set, it just take only for the yield data. Okay, only for the yield data. Okay, so you can see this is this column, this x basically we are just remove this yield data and stored other
Yes.
data,
Yes.
moisture, speed, width,
Yes.
and moisture, speed, and width. But y, these are target variable. So y, we simply input the yield data. Okay, and spill the data. So now run
Okay,
the
now I
code.
get.
Yeah, so if you check now, suppose for the x, just x, we can get this type of thing. Suppose I want to print the y, we find out only for this type of yield data. Okay, so we can create the two data set. We simply split x and y. X is stored our properties. So this is the property, or this is the property, and y is the our target. Okay, y is our target. I want to make the yield prediction. So your target is the y. So now x, all the input variable we can input without yield, and y is the yield values. Okay, which I want to predict. Okay, so this is my target. Y is my target. So now if you check the shape, suppose just recall the y dot shape. So y is the uppercase. So you find out the total how much training sample shape is 628. It means that this data have total 628. We find out 628 values or point information, 628 yield prediction or yield data, 628 we find out. So now when we apply the machine learning or linear regression, we need to import some library. So first library I simply put from sklearn dot model selection and import train test spilled. Okay, just simply import the train test spill data, and then from sklearn import our model. This model called the linear model. Then from sklearn dot linear model and import the package package is reads, and then from sklearn, and also linear model, and import the lasso. So now import all of those, there is no problem, and you can simply search here, suppose sklearn model. So now we can easily get the different types of, you can see. So you can simply just simply click on here, so you can get the some theoretical part about that. You can see the supervised learning, so we can use the different types of linear model. Okay, so lasso is one kind of linear model. Okay, Rees, regression and classification, we also import the Rees, lasso. Okay, or also you can see different perceptron or passive, so it used for the another way. So you can see, so you also try to read this type of thing for the scikit-learn model. You can get some theoretical part. Suppose I simply click on the lasso, so now I can see how we can easily use the lasso. Then we can easily get the idea for the lasso. Okay, you can see the lasso is a linear model that estimates the sparse coefficient. It useful to some extent due to its the tendency to prevent the solution. So this type of theoretical part we can easily get from this scikit-learn website. So user guide, you can see, so it's helpful. You can also get some demo data set also for the practice. Okay, so you also try to read this type of scikit-learn website, then you get a lot of idea about this type of theoretical part, how it will work, this type of model. So I simply import this type of model and take the new cell. So now I need to spill the data. Suppose some train set and some test set. Train and test, I need to spill the data. So I have two data, you can see that I have the X data and I also have the Y data. Okay, so this I need the X test and X train. I also need the Y test and Y train. So then I spilled. So for that I simply take the variable. Suppose I put the variable name is X train. I take another variable, suppose X text. Then another variable, suppose Y train. Then put Y test. Okay, so I simply put the X train, X test, Y train, Y test, and I just spill the data using this function. This function called the train test spilled. Just I copy and paste here. So now I define the X and Y. So I simply define X and Y. So I already spilled the X and Y. You can say X and Y. So I simply define. So now how much training sample? How much train? So I want to train, suppose 70% data I want to train and 30% data I want to test. So just input here the test size equal 0.3. I simply define the test size 0.3, and then random stat, it's a 42 default, we are use the 42. Okay, there is no problem. So we define the test site 30%. So now it automatically take the 70% for the training. So when I define the suppose 0.4, then it automatically take the train set 60%. Okay, so I put the 30% test set and 70% for the 10 and spill the data. Okay, so X train, Y train, X test, Y test, run the code. So now if you check the X train data, suppose X train, so now you find out this type of X train data. If you check the shape, so we find out this is the shape X train. Suppose I need to check the shape for X Y train or X test, I need to check. Okay, this is the X test. Okay, so this is a 30% data, this is 70% data for X train and X test. And then suppose you check for Y train shape, we find out, and suppose Y test shape. Okay, we find out this type of data. So now we spill the data. Okay, so now I want to use the X train and Y train. I just use the X train and Y train to train my model. Okay, to train my model, I just use this X train and Y train. So how I need to create the model? So how I can make the model? So for creating the model, so we simply take a variable, suppose model equal, and I call the linear model. So I already defined, you can see the linear model, and from here I put the linear regression function, regression function, linear regression function, simply call and run. So model is okay. So after this creating the model, so this model I need to connect with my train set. Okay, so just I simply call the model and then apply the fit function for train. So I need to train X train, just I copy, and also define the Y train and train my data. So it's trained, we find out this type of regression. If you check, so we find out this type of you can see the parameter. Okay, we find out this type of parameter. Further, you can also copy X, also copy this type of true. Okay, total. So now we create this model. Okay, so now this model I simply train my model X train and Y train. So now I want to check some coefficient. Okay, I want to check some coefficient. Suppose this model you can also can predict. Okay, suppose, okay, let me show you for the predict first, how I can predict using this model. So this is my model. Okay, so now I want to predict. Okay, so for that, just take a variable, suppose Y. Suppose I put the variable as the Y predict equal, call the model. So this is my model. Okay, this model I simply connect this model, use the predict function, predict the X test. So just call the X test and run the code. So it predict. So now you want to check, suppose prediction score. Okay, or model score, or model score. So for that, simply call the model and apply the score, and for a score basically X train, and also call the Y train. So now we find out the model is scored 71%. We find out that for the model performance. And then if you check
that 71 is
yeah, please.
Is that 71 or 7%? 0.07.
Yeah, 0.07. Yeah, 0.07.
So it is 7%, not 71.
Yeah, 7%. Yeah, 7%.
So is that score is reasonable or it is very low?
It's a demo data. It's not the accurate data.
Oh, okay.
Okay, so when you work the practically, then you just more about the more accurate data. Okay, so it's just a demo data we create for the practice. And suppose you want to check for the model score for the test set. So for that, simply call the model and score. For the score, we simply put X test and Y test. So X test and also put the Y test. So you can see only 4. Also for the test score and also train score we calculate from our after creating the model. Okay, as well as we can also compute suppose different other metrics. Suppose I want to compute from this model I want to compute suppose mean absolute error. Okay, suppose MEA, mean absolute error, or I can compute suppose mean square error. Okay, mean square error, as well as you can also compute the root mean square error. So this type of metrics we can also compute. Okay, so suppose further we need to import the another library to compute this type of things. So just I simply put the from sklearn metrics sklearn metrics and import mean absolute error. Okay, and also mean square error. So just use the same. So from this library we simply import this mean absolute error and also mean squared error. So just simply import. So now when compute suppose mean square mean absolute error, I take a variable and then just call this function mean absolute error between y test and also prediction value. So y predict. So now it computes the mean absolute error. Okay, so then I simply print, then you get the idea. Suppose mean is MSE, mean squared error I want to compute. So just call the mean squared error. I want to just call this library and then put here the y test and y predict. So then we find out that our prediction mean squared error. Then I want to compute suppose root mean square error. So root mean square error, we need to apply the function square root of mean square error, y test and y predict. Okay, this is the formula about that. Okay, so for that just take the variable RMSE and call the square root. So a square root function, this function we find out from the numpy. Okay, let me import the numpy. Suppose import numpy as np. Okay, just I simply import the numpy because we also need the numpy in here. So import the numpy, I call the np. Okay, and apply the sqrt, square root of mean squared error. I simply call the mean square root error between y test and y predict. Okay, then we find out the result for root mean square error. So now run the code. So further we simply print the result. Suppose print. So first one it show the result for mean absolute error. This one. Okay, then print. This one is for it represent the mean squared error. So just call the MSC. And then if you check, suppose print, it's indicating about the root mean squared error. Okay, just I define RMSC and run the code. So now we can get all of result. You can see for the mean absolute error for our model, mean square error or root mean square, you can easily identify this type of things from here. Okay, so now we can create this type of things, and if you want you can also check, suppose coefficient. Okay, suppose we can also check the coefficient for each variable. I want to compute the coefficient for each variable. So for that we simply use the another code to check the coefficient value. Okay, coefficient value value for each variables. So how we can check for the coefficient value for each variable? So for that we simply create a loop or create a function, so then we can easily put all of those. So for that simply take the for. Suppose I put the for loop for, and I take a variable, suppose idx, comma, I just put the column, take the another variable column name in, and I use a function inner inu, okay, ENUMERATE, okay, and define the x train, simply call the x train. Okay, x train, and put at the columns. Okay, so I just create column in this type of x train. Basically in the x train we find out the three column. Okay, three column, basically three different variable. Suppose for moisture, speed and width. Okay, we find out three different variable in here in the x column. So just I use in here. So for that I simply print coefficient. So just I call my model. So model, because I put the model, you can say when I make the model I put the model. So from this model I simply check the coefficient. So put at the COEF. Okay, coefficient. This is the function. This function help you to compute the coefficient from your column is variable. Okay, is variable, and I define this idx. Just I define idx. Okay, so we need to define the another function dot format. Okay, format function, close the bracket. So we just take the data this format. I will show a problem. Okay, dot format. Okay, let me try without format. Okay, fine, what you can see. So this is the one coefficient, this is the another coefficient, this is the another coefficient value, but we are don't understand about the which value. This is the speed, or so further we need to add the another information. Okay, so just we simply add some extra code. Suppose I simply write here the coefficient string, suppose for I put the empty is, also put the empty, so it show the name. Okay, it show the name, and then put the dot format. I just use this format, and format will be I put the column name. Okay, just I put the column name, so this column name, and define the model coefficient and close the bracket. So now you can see, I think so you can see now we find out this type of result. So each column, suppose for the moisture, we find out this coefficient value. Speed, we find out this type of coefficient value. Weight, we find out this type of coefficient value. So if you want, you can also add the more other variable. So in this case, we for the example, we set the only for the 3 variable. So then we also check the all of variable coefficient value. Okay, if you check, suppose okay, so this is the process, because in this time we are just add only for the 3 variable, that's why it shows only for 3. So now our model is done. Okay, we create the model and also check this type of accuracy. Okay, so now after create the model, we need to apply this model to our complete data set. Okay, in our complete data set, we simply apply this model. So let's go how we can easily apply. How to apply this model in our complete data set. So for that, we simply just make the combine all of data. Suppose just take a variable GDF to predict. So I call the PD pandas and put the concat function. Okay, to combine all of data, basically this type of data, GDF1, GDF2. Okay, we simply combine all of data. All of that is simply combine all of GeoDataFrame. So I just make a list and put here the GDF1, then GDF2, then 3, then 4, then 5, finally 6. Okay, and make the list this type of data. So now run the code. Okay, we have to use the underscore, because we put the variable name with underscore. Okay, so it's okay. So now if you just show the result, suppose just GDF print. So I guess we find out this type of data. Okay, X, Y, timestamp, moisture, speed, wind, yield. Okay, we find out this type of column. But now I want to remove all of those column. Okay, suppose this type of column I want to remove. Okay, I just remove all of column from my data set. So how I can remove So just use the drop function. So just put here I use the same variable, okay, and call this same and apply the drop function. Drop and mention the column name. So put here the columns and make the list all of columns which I drop. So I want to drop X, I want to drop Y, I want to drop time stamped, time stamp, I want to drop Mercier, then I want to drop speed, then I want to drop width. So simply drop out all of column and also yield and also this column. Finally, geometry column. Okay, so I simply write all of column and just apply the drop out function. So now run the code. Okay, it also okay. So now if you check the variable, this variable just store it only for the index, only for the index. Okay, so in this case, why I remove all of those and just keep only for the index? Because I want to add the prediction column. Okay, just I remove all of those and I want to add the prediction column based on the index. Suppose for the first point, what is the prediction yield I need to add in here. For the second point, what's the prediction yield, I simply add in here. For the third number point, what is the prediction data, I simply add. So for the region, I simply remove all of column in my data set and then I skip only for the index. Okay, that's only for the index. So based on the index, I simply add all of prediction data or prediction column, I simply add based on the index. So let's go how we can easily add the prediction column. So for that, just take the new cell to connect the prediction column. So just take a variable, suppose full predict and call the model. So I already defined the model. So this is my model I want to use and apply the predict function, predict, and after that predict using the index, this model. So now run the code. Oh, it show a problem. This problem is that variable exceeds. So okay, we predict using the linear regression. It show the problem. At least one array data type is required. Okay, at least one array. Okay, in this case, it called that at least one array data type is required. Okay, so I simply, okay, I just only for the one array. Suppose I just take only for the moisture. Okay, and remove all of those. So now try to check again, run. And also, suppose I just keep only for the int. We can get only for the moisture, speed, and weight. So now I want to predict. Okay, so it's work, yeah. Okay, so we need we need to add the one array. Okay, not need to remove all of those. So I simply keep only for this moisture, speed, and weight. Okay, or you can take only for the moisture or speed or wind, or take the any one column. Okay, not only for the index. Okay, for this is the requirement. So now I try to predict. Okay, there is no problem. So if you just simply try to show the result, so it creates this type of prediction that I can see, this type of prediction yield for each point. But these things I want to add as a column. Suppose I create the another column which represented the prediction column for each point. Okay, each point it display the prediction column. So for that I simply create a column and add the data with my column. So for that just call. So I want to add the column. Suppose I want to add the column in here. Okay, add the another column in here. So just call this variable and create the column name. So just put the column name. I put the column name, suppose yield predict. I put this type of column name. Then put the equal sign and call the full predict. Just I copy and paste here. So now this type of data is stored in this column. So now run the code. Okay, and I want to display the result. So just I copy. So now it's added the new. You can see find out that yield prediction. Okay, so I hope you also get the idea how we can easily predict the yield for the each point. Okay, suppose for this point or for this coordinate, what's the yield for this point? So it creates the yield prediction column. We simply connect. Okay.
Yes.
Okay. So now further we display the map. So one by one I try to show you that how we can easily create the productivity map. So it show the only for the numeric value for each coordinate. We are just apply the linear regression model, and further we simply predict our value for each coordinate. For this coordinate we simply predict our value. So now we try to discuss about that how we can easily add the productivity map using this type of prediction result, using this type of prediction map or prediction data, how we can easily add the productivity map for our agricultural land. Okay, so let's go and try to show you that how we can easily work with that.